The history of the axiomatic method is closely entwined with the history of logic itself. Like logic, the axiomatic method dates back to the ancient Greeks. The most famous ancient text that uses the axiomatic method is Euclid's The Elements, which applies the axiomatic method to the study of geometry. While investigating the properties of points, lines, and geometrical shapes, the Greeks discovered the notion of proof that lies at the heart of deductive logic.
And Dave, did you know that the reason geometry was of interest was because they were farmers and they were dividing up land? And in fact, by the time of the ancient Greeks, an enormous number of discoveries about geometry were already known. The ancient Babylonians knew what we now call the Pythagorean theorem, for example. But for the Babylonians, geometry was an empirical science. Facts were discovered by observation.
It's not actually obvious to me how the Pythagorean theorem is relevant to dividing up land into fields, but let's go figure. But then someone had a brilliant idea. I'd like to say it was me, but it was before even my time. They realized that the facts of geometry were logically related. Some were consequences of others, for example. So the idea was to choose a handful of obviously true facts and then try to derive all of the other facts systematically from those starting points.
Right, and the starting points, the starting truths, were called axioms, or sometimes postulates. And their consequences were called theorems. Since the axioms were meant to be necessary truths and the rules of inference are deductively valid, the truth of the theorems was guaranteed.
This idea was generalized into other subjects, and the axiomatic method was born. Given any subject matter, we write down a set of obvious, simple facts about the subject. Some of these simple facts, some of these axioms, express logical truths about the meanings of the predicates, and others express basic facts about the domain, like our fourth shape axiom. Then we deduce new facts using these axioms and first-order logic alone, and we can be sure that everything that we can deduce by this method is on just as firm a footing as the original axioms.
So let me summarize what we've talked about today. So we've introduced the notion of the axiomatic method. Now, the axiomatic method was originally we motivated it by talking about meaning postulates. These were just claims that described important facts about the meanings of the predicates that were contained in the claims. And using these meaning postulates, it allows us to turn analytic consequences into first-order consequences because we express those important facts about the meanings. But really, the axiomatic method is actually more general than that. It allows us also to explicitly state certain other basic facts about the domain that we're reasoning about. And so it allows us to make those explicit and turn our reasoning into first-order valid reasoning. So this is actually a good general way to make your assumptions explicit. And if, for example, you're arguing and you disagree, you have the same premises apparently, and you disagree about the conclusion, it may well be that there are some implicit facts that you're assuming that are different. And so if you make those assumptions explicit, then that can make clear where you're disagreeing. That's enough for today. Thanks.